こんにちは。メルカリ Go のオーガナイザーをしているセガです。今日はメルカリ Go24 回ということで、GopherCon 2023のリキャップの回をやりたいと思います。ハッシュタグはメルカリ、メルカリ Go、Gophers スラックでもスラックチャンネルがあって、メルカリ Go で開催しております。で、まず、この回を始める前に、メルカリ Go について説明したいと思います。メルカリ Go は、メルカリグループのエンジニアが Go について、いろいろ、話す場になっています。で、その中のトピックとしては、社内での Go の採用事例だったり、個人開発で得た知見だったり、最近の Go のトレンドだったり、いろんな形のトピックをこの回の中で紹介していきたいと思います。改めてハッシュタグはメルカリ Go、シャープメルカリ Go でやっています。で、あと Gophers スラックの中では、シャープメルカリ Go というチャンネルがありますので、そちらでも、この情報を共有しています。はい。で、先ほども言いましたが、今回のテーマは、GopherCon 2023がサンディエゴで開催されたのですが、そちらのリキャップになります。で、改めて、事前にお伝えしたいこととしては、今回の、発表内容については、ほとんどが英語の発表になります。で、途中で、発表内容が英語に切り替わりますが、その部分については、ご理解の上、ご視聴いただければと思います。また質問やフィードバックに関しては、日本語、英語、どちらでも受け付けていますので、お気軽にフィードバックや質問をいただければと思います。はい。それではですね、今日、登壇してもらう、予定、してもらう方としては、6名います。GopherCon 2023のリキャップ、Concurrent Data Structure and CPU Caching with Go、あとリキャップ Automatically Instrument や Go Source Code with Orchestration、あと、GopherCon 2023 Overview、あと Navigating the Series of Data Migration Journey and Go OPs, talking about Go and OPs になります。では、最初の、セッションの発表に移りたいと思います。最初のセッションは、私がやります。で、今回の、発表については、英語でやりたいと思います。それでは始めたいと思います。Yeah, hello again. I'm Naxiger. Today, I want to talk about the GopherCon 2023 recap. First of all, let me introduce myself shortly. I'm Naxiger. My handle name is nsega, and I'm a backend engineer in Mercari US since December 2021. And I joined the Mercari JP in November 2018, and I moved to the Mercari US from Mercari JP. And I also one of the Mercari Go organizers. And my Go experience is for more than 5 years. And currently, my current interests are Go, GCP, Kubernetes, and generative AI. Here is the agenda. Today's agenda are 3 items. First, what is GopherCon 2023? Second, introduce the session, the future of JSON. And the third one is conclusion. Let's go over the first item. What is GopherCon 2023? First of all, I'd like to share the GopherCon itself with you. GopherCon is an annual conference which began in 2014. And this conference is mainly dedicated to the Go programming language. And this conference is organized by a community-driven group of developers who wish to promote the use of Go the formation of an inclusive and supportive Go community and the education of Go developers. And what is GopherCon 2023? GopherCon 2023 is taking place in San Diego from September 25th to 2018th. The content of this conference were presentations such as keynotes, tutorial session, and lightning talks, workshops such as generics, DevOps, generative AI, something like that. And lastly, networking. We attend participants can see Go team in person, and also we can see their Go developers at the same time. Let's move on to the second item. Introduce the session, the future of JSON. This is one of the scenario of this session. The reason why I picked up this session is that this session was one of the most impressed in this GopherCon. This session also describes that current encoding JSON package trend and what kind of issues this package have, and Go team what kind of plan Go team do that. And this presentation was spoken by Joe, who was from member of technical staff Tailscape. Here is their main collaborators, and there are many famous Go developers who can contribute to the encoded JSON package. And first of all, I'd like to share the summary of this session with you to grasp the overview of this session. And one of the summary is what are the problems with V1 encoding JSON, and second, how can we fix them in encoding JSON V2, and how would V1 and V2 interoperate. And lastly, the open discussion encoding JSON V2 is opened on October 5th. Let's dive into one by one, each topic one by one. First, the package encoding JSON is one of the very popular package in Go standard library. And as you can see, encoding JSON has been already imported by more than 1.3 million imports. And this number of imports is top 5 in Go standard library. But the package encoded JSON have some problems. There are mainly 4 problems. 1, missing functionality. 2, API dependencies. 3, performance limitations. 4, behavioral flaws. I'd like to dive into each problem one by one. Number 1, mission functionality. As you may know, encoding JSON has been already requested by Alto proposal in GitHub. And one of there are some examples like specify custom formatting of time.time and omit specific Go values when marshalling, and marshal in new Go sizes and maps as empty JSON arrays and objects, and inline Go types without using Go embedding, something like that. Like these requests, other than like these requests, there are many requests to enhance encoding JSON. And second, API deficiencies. Currently, encoded JSON is no easy way no easy way to correctly unmarshal from IO.reader, and options can be set on the encoder and decoder tabs, but cannot be used with the marshal and unmarshal functions. And also, the functions compact indent and HTML escape write to a byte.buffer instead of something more flexible like a byte array or IO.writer. This limits the usability of those functions. And third problem is performance limitations. There are some some performance issue from the perspective of JSON package. For example, marshal JSON, unmarshal JSON, encoder.write token, decoder.token, and lack of streaming. One of the remarkable example of related to the performance limitation is unmarshal JSON. And as you may know, Kubernetes Kube Open API has issued this report this report says that deserialization encoding JSON to Swagger is slower than deserializing JSON to map interfaces. So such performance issue has become serious problem these days. And last problem is behavioral flow. There are various behavioral flows identified with the JSON package. If you are interested in detailed behavioral flow, open discussion has already described it. And next is how can we fix them in encoding JSON v2? As for encoding JSON v2, Go team has their goals, such concept, mostly backward compatible, more correct, more performant, more flexible, easy to use, it means how to misuse and avoid unsafe. And here are the things their proposal aimed for such concepts. JSON serialization can be broken into two primary components. Synthetic functionality that is concerned with processing JSON based on its grammar. And this functionality maps to encode and decode. And second component is semantic functionality that determines the meaning of JSON values as Go values and vice versa. This function also maps to marshal and unmarshal. And this proposal includes the creating two packages, JSON and JSON text. JSON text is used for synthetic functionality, and JSON for semantic functionality. JSON package is used for their semantic functionality built in terms of JSON text. And here is a diagram of encoding JSON v2. And as you can see, JSON package has their 6 functions: marshal write, marshal encode, unmarshal read, and unmarshal decode. On the other hand, package JSON text has their some types: encoder, decoder, value, and token. In more detail, when it comes to package JSON, as I mentioned earlier, 6 functions have 6 functions come, and mainly the marshal and unmarshal functions mostly match the signature of the same function in V1. However, there are behavior differences between V1 and V2. In more detail, please see the Go JSON experience JSON repository. And on the other hand, as for package JSON, JSON text package, this package has 4 types: decoder, encoder, value, and token. As I mentioned earlier, there is some behavioral change between V1 and V2. And this behavioral change are still in discussion in GitHub issues. For example, embed UTF is rejected by default. Duplicate names are rejected by default. JSON objects names use case-sensitive match. New slices are marshaled as an empty JSON array. New maps are marshaled as an empty JSON object, and many other smaller changes. And the last topic is how would V1 and V2 interpret? Go team is designed to make it interpret well with existing functionality that operate on the V1 signature. They propose their such functionality, Marshall Frank V1 and Marshall Frank V1. Also, there will be a Marshall Frank V2 and a Marshall Frank V2 function. These functions are able to support such interoperation between V1 and V2. Yeah, again, this is a summary of the session. First, what are the problems with V1 encoding JSON? Second, how can we fix them in encoding JSON V2? And third, how would V1 and V2 interpret? And lastly, the open discussion encoding JSON V2 is opened on October 5th. And one of the things I want to emphasize about this session is that, as you can see, Go JSON explains JSON repository has explained a lot of test and trial, such as performance, tuning, and benchmark. And at the same time, there is a whole meeting notes and a recording on YouTube list recorded the whole code review about encoding JSON with Go team. And all sites are also opened. And if you're interested in this record, I strongly recommend that you should go over these resources once. Yeah, this is a conclusion. There are 2 points I want to conclude this time. One, attending GopherCon could give us valuable insights and memorable experiences. And second is developing encoding JSON V2 will be one of the beneficial improvements from the various perspectives in Go community, such as keep open discussion, aim for better consensus, performance tuning, set benchmarks, and make important announcements. I wanted to refer such how to proceed with the big future with the team for my next future development. Yeah, this is there for information. Yesterday, one of the other presentators, Komatsu-san, presented same recap, the future of JSON in Go at the GopherCon 2022 recap hosted by Gopher Japan yesterday. This presentation slide is also informative. Please check it out as well. Yeah, that's about it. Thank you for listening. Uh, それでは、自分で言うのもおかしいですけど、QA タイムに入りたいと思います。で、今のところ QA は、来てなさそうなので、もしあればまた拾いますが、次の発表に移りたいと思います。So, Derek, your presentation will next. I will pass on the mic.
Thank you, Sei-san. All right. Hello, everyone. My name is Derek. I am a back engineer at Merpay on the payment platform. So today I will be sharing about my favorite presentation at GopherCon and also sharing some information about CPU cache that we as developers may not know. So let's get started. So my favorite presentation was Building a Highly Concurrent Cache in Go by Conrad Rach, who is a staff engineer at Reddit. Reddit is a massive social media platform. It has the world's top 17 of internet traffic, and you can see from these statistics, they have a lot of traffic to handle. So before we begin, what is cache? So cache is a high-speed storage. We use it to store data temporarily for frequent reuse. It's really good for data that is expensive or resource-intensive to get and is likely to be accessed again, such as calculated or data from API calls or data from a database. So let's look at the Reddit scenario. So on their side, they have Kubernetes pods running their application. They had a P99 latency of 100 milliseconds, and they were able to reduce this down to 5 milliseconds by implementing Redis, a remote distributed cache cluster. So the pods will go to the cache cluster for its cache. So this is very performant, it's very scalable. From their analysis, they saw that they were getting 5 to 20 million keys on their lookups on their cache cluster alone. However, this is very expensive for cloud costs, and this is just not sustainable. So they implemented another solution, local in-pod memory caching. So this is where they added a cache layer to their Kubernetes pods with their application, so that before they call the Redis cluster, they would check their local cache. This was really good. They were able to reduce the cost of calling Redis, and from their analysis, they were getting about 90,000 operations on their local cache for each pod. So this was an amazing improvement. The next improvement was to develop their own data structure for their use case. So they wanted to build a concurrent cache. Their advice was to start off with a very basic, simple design. So here you can see we have a very basic cache implementation. And this is going to change. So this mutex becomes a read-write mutex. And then you can see the setter and getter functions, their parameters and return values are going to change from single values to multiple values. So here you can see that it's been replaced with a map with key values of string. And this was what they wanted for their data structure to work for their system. So at each time that they make a change to this, they are doing iterations. And for each iteration, they want to do profiling and benchmarking so that they can, one, profile their CPU, their memory, Go routines, mutexes, threads, but also optimize for concurrency contention. So here are some examples of using pprof and the commands to run pprof. The other thing is benchmarking. So our test suites include benchmarking. So we can use benchmark to do analysis. For them, because they are doing concurrent cache, they also use the run parallel. This allowed them to do analysis on the concurrency in their benchmark. Another thing that they had to think about is cache eviction. So with cache, there is going to be a set amount of capacity that you can store. If we keep adding to the cache, eventually we'll have an out-of-memory issue. So they need to look at cache eviction policies, things to remove and replace cache data for new and useful data. So here you can see I've listed 4 cache replacement policies, and basically they went through each of these 4, and at each change, they did profiling and benchmark. They eventually decided on DLFU after going through the analysis. They also went into maps. So in Go, we have choices for using maps. We have the Golang map, we have the sync package map, and there's also a third-party library called xsync, which also provides a map concurrent data structure. Each of these do concurrency differently, such as Golang map requires us to use a mutex, whereas the other two are built to be concurrent as is. But they have their own use cases that you have to respect. So for the xsync map, they are able to produce a faster and more efficient map than sync.map. This is by dividing their map into submaps or shards. And then for each of these keys in the map, they all have their own cache line. So let me talk about cache line after I explain a few things. So because I want to talk about CPU cache, let me just go through the basics of our memory and our CPU. So main memory, as developers, we know that our application is loaded into main memory along with its variables. Our CPU these days have multiple cores. And you may not know, but you may have seen these letters, but the CPU has cache. It's built into the CPU. So we have L1, L2, L3, and each core has their own L1 and L2 cache. And the L3 cache is usually shared among multiple cores. So let's just look at the performance. So using computer cycles, we can see that L1 is very fast at 4 cycles. And as we keep going down to main memory, it is 100 cycles, much lower than L1. And for the cache size, we can see that the L1 is measured in kilobytes. And as we go up, it goes bigger with kilobytes than megabytes. And then RAM or memory has gigabytes. So let's look at a scenario. So let's say we have an application. It has a Go routine and it wants to update variable A. So what we do is we get variable A from main memory and put it into our CPU core 1 L1 cache. But you might have noticed here, there's variable B in here. Why? The reason is because of cache line. Cache line is a size of 64 bytes. And as you can see here, variable A and variable B are in the same 64-byte cache line. And that's why they were pulled together into the CPU cache. This is called spatial locality. When we pick an address, addresses near that address are also taken along with it. It's kind of like taking a basket to your bookshelf. You're looking for a specific book, but you also see that the books next to it are going to be useful. You might not use it now, but you think you might use it in the future, so you bring it back to your desk, just like CPU cache. Let us introduce another scenario, but this time we have 2 cores. The first core wants to update variable A. So like before, it gets both variable A and B and updates variable A. No problems here. But now we have core 2 who wants to update variable B. So just like core 1, it gets variable A and B from memory because they are in the same cache line. You might think there's an issue here, but there is a thing called cache coherence, which synchronizes the data that are in these caches. What cache coherence does is that it invalidates the cache line in other cores when one core updates it. So in this case, because core 2 is going to update this cache line, the same cache line that exists in core 1 is going to be invalidated. And if core 1 wants to read A again, then it needs to reload this cache line again from main memory. And then then core 2 can update B with no issues. However, we have an issue called false sharing here. This is the scenario where we have 2 cores which are modifying the same cache line, but are touching different variables. And this is a performance issue. This is bad for performance because it has to keep doing cache coherence, where it keeps invalidating the data from each other in order to update it. And they also have to reload the data from main memory. And if this is in a loop, then we have a thing called cache line ping pong. So as you can understand, this is bad for performance, and we need to understand this for our concurrent data structures. In summary, when building our own data structures, we want to start simple. We want to profile and benchmark often at each increment, and we may want to also investigate CPU caching. Our concurrent data structures have performance issues when it comes to CPU cache, and we need to see if it's missing or hitting the cache. And we also have to consider cache line sharing. All right, that is all. I hope you enjoyed that and learned something. Thank you everyone for listening.
Thank you for your presentation, Derek. I'm also attending this session, and I can't remember this session was really impressed as well. And it seems there is no additional question for your presentation. So I want to move on to the next presenter. So next presenter is Komatsu-san. Komatsu-san, are you ready?
はい、それでは、Recap Automatically Instrument Your Go Source Code with Orchestrion というタイトルで、発表を始めたいと思います。今回は日本語で発表します。はい、簡単に、自己紹介します。メルペイでバックエンドエンジニアをやっている小松と言います。2022年の4月に入社して、ペイメントコアチームというところで、デリックさんと一緒なんですが、決済基盤の開発をしています。で、今回紹介するセッションは、データ読者のエンジニアによる Automatically Instrument Your Go Source Code with Orchestrion というタイトルです。主な内容は、Orchestrion というデータ読者が開発している CLI ツールの紹介になります。このツールの機能は、とてもシンプルで、Go のソースコードに対してデータドグで APM を計測するコードを自動で生成することができます。実際にはコード生成をするというよりかは、コードの自動係数を行うような機能になっています。で実際にリポジトリが公開されていて、データドグオーガニゼーションの中に入っているので、実装を見ることもできます。ご存知の方も多いとは思いますが、一度データドグのトレーシズについて簡単に紹介します。データドグトレーシズはこのスクリーンショットにあるようなリクエストフローの中で各コンポーネント間でどのような作用があるか、もしくはタイムライン形式でそれを表示してくれる機能になっています。一つのトレースは一つ以上のスパンを持っていて、スパンは HTTP のリクエストの受信だったり、データベースの呼び出し、あるいは他のマイクロサービスを叩いたときなど、処理に時間がかかるような、コードに対して、それに対応する単位がスパンになります。メルカリではデータドグを主にモニタリングツールとして使用しているので、レイテンシーの確認やボトルネックとなるデータベースやマイクロサービスを簡単に把握することができます。次に実際のコードではどのようにデータを取得するかを紹介します。左はトレースの取得をしない、誰しもが書いたことのあるような HTTP ハンドラーです。これにトレーシングの機能を追加しようとすると、右のようなコードになります。書いてあることはシンプルで、メイン関数ではトレーサーの起動、あとデファーで終了。で、do something ハンドラーの中では、スパンの初期化とデファーによる終了を記載しています。一見とてもシンプルな記法なんですが、HTTP ハンドラーを追加で増やしたりとか、トレーシングの対象が増えていくと、このコードのように、その度に同じようなコードを書く必要が出てきます。トレーシングの追加漏れがないかどうかを確認する必要もありますし、ディファーで書いているフィニッシュメソッドを呼ばないと内部で予期せぬ動きが発生したりするので、ご注意をしながら書く必要があります。このめんどくささは、Go の文法のシンプルさに起因するものとも言えると思います。というのも、Java や Python だったら、アノテーションとかデコレータのような、一行で関数の動きをラップするような構文があります。実際にデータドックの Java や Python の SDK では、この右の図のコードのような、アノテーションやデコレーターでトレーシングの実装が可能になるようなものが提供されています。これ同じようなことを Go で実現しようと考えたときに、Go は文法が非常にシンプルであって、AST のパースが簡単という観点からも、自動でトレーシングのためのコードを生成する方法というのが、オーケストリオンのモチベーションになります。まずはオーケストリオンというツールがどのように動くかを見てみたいと思います。先ほど例に挙げた左のコードに対して、オーケストリオン -w ドットと実行すると、右のコードが出力されます。インポートされているインストルメントというパッケージはオーケストリオンが提供しているもので、これを見てみると、まず init とハンドラーのラッパーが追加されていることがわかります。 まずイニットについて詳しく見てみると、これは中身はとても簡単で、手動でトレーサーを起動するときとほぼ同じようなことが書かれています。返り値としてデファーで終了するためのストップも返されています。また一応内部で With Orchestrion というオプションでバージョンの埋め込みも行っています。基本的には手動で書くときと同じ内容の動作になっています。次にハンドラーがラップされている部分を詳しく見てみると、まず左上のコードでは、instrument.wrapHandlerFunc ので HTTP のハンドラーがラップされています。でこの部分を見てみると、左下では、このハンドラーが http:/trace.traceandserve という関数でラップされているのがわかります。でその中身も、この HTTP トレースというのは、データドックがネット HTTP パッケージで簡単にトレーシング付きのハンドラーを実装するための別のラッパーのようなものです。少し余談ですが、このラッパーはddTraceGo のコントリブというディレクトリに入っていて、ネット HTTP パッケージ以外にも有名な HTTP のフレームワークだったり、もしくはデータベース SQL とか gRPC とかのラッパーもあります。ラップハンドラーファンクは基本的にそれを使って、ハンドラーをラップするだけになっています。ついでにさらに深掘って見てみると、右上の図では、その http trace. start request span というメソッドでリクエストがラップされていることがわかります。でさらにそこを見てみると、手動で書いたときと、手で書いたときと同じように、スタートリクエストスパンの中で、スタートスパンフロムコンテキストが呼ばれていることがわかります。つまりこのラップのファンクションは、内部では手で書いたときと、ほとんど同じようなことが書かれていることがわかります。また、オーケストリオンは -rm オプションをサポートしています。つまり、コードの生成を行う前の状態に戻すことができます。他にも dd:/span というマジックコマンドが用意されていて、これを関数の頭につけることで、トレース時のタグも埋め込んでくれるようなコードを生成してくれます。コロンを使ってタイプリクエストといった感じでキーバリュー形式のタグも指定できますし、ここに変数名一つを書くことで、その名前のキーで実際のその値、今回の場合は r.method の内容が書き込まれるような、タグを生成してくれます。オーケストリアンの内部では DaveDST というパッケージを使って AST の解析を行っています。Go の標準パッケージである GoAST もあるんですが、こちらはコメントを、ノードに付属しないようなパースをする設計になっているため、コードの生成ではなく自動係争をするっていう、オーケストリオンの、概念に従うと、DST を使う必要があったようです。最後にこのセッションの聞いた感想を話したいと思います。まず、オーケストリオンは、機能がまだとてもシンプルということもあって、簡単に使えたりとか、変更が可逆であるということから、すぐ試せる点は、とてもいいところだと思っています。一方で、まだ機能はかなり不足しているかなと思っています。例えば、特定の関数の生成は無視をしたいみたいな、イグノアのようなマジックコメントが例えばあってもいいのかなと思いました。他にも、オープンテレメトリーには、まだ対応していないということで、公式のリポジトリには将来的には対応すると書かれていますが、まだ対応していないという点で機能が不足しているかなと思います。とはいえ、ddTraceGo パッケージの中で、トレーサーコンフィグという構造体があるんですが、その構造体にはもうすでにオーケストリオンコンフィグというフィールドを持っているようなので、トレーサー本体が、オーケストリオンがもう今後入ってくることを期待しているというか、考えられてすでに実装が追加されていることになるので、今後のデータ読者による機能の強化に期待したいと思っています。今回はオーケストリオンというデータ読トレースを自動係争してくれるツールについて紹介しました。まだプロダクションで使うことはかなり厳しい状態ではあるとは思うんですが、興味を持った方はぜひリポジトリなどを覗いてみてください。以上で発表終わります。ご清聴ありがとうございました。
小松さん、発表ありがとうございました。ですね、オーケストリオンの発表は自分も、多分確か隣で聞いてたと思うんですけど、すごく、深いところまで、アルゴリズムとかから、データドックの人が、データドックじゃない、グラファラン、発表されてた方が対応してたのを思い出して、すごい今、発表内容を見て、こういう内容だったなっていうのを思い出すことができました。ありがとうございます。で、一個質問が来てまして、自動生成してくれるのはすごく便利そうだとは思うんですけれども、その反面、スタックトレースが書き換わることになったりしないですかっていう質問が来てるんですけど、その点について、コメントいただけますか？
そうですね。Go のスタックトレースっていう観点で言うと、もちろん中で呼び出す関数だったりが変わっているので、若干書き換わるっていうのは、その通りだと思います。はい。
わかりました。じゃあ、それを踏まえた上で使うようなことを考えていかなきゃいけないっていうことになりますよね。
そうですね。ライブラリ自体の用途としては、データドックに APM を吐くこと、トレースを吐くことなので、そっちで見る上では、あまり問題にはならないのかなと思います。
はい。わかりました。ありがとうございます。それでは他に、質問が来ていないようなので、次の発表に移りたいと思います。小松さん、ありがとうございました。
ありがとうございます。
では、次のプレゼンテーションは、テンリンさんからの GopherCon 2023 Overview になります。Telling, I want to pass on the mic to you. Are you ready? Okay.
Hello. So my name is Zhou Xuanpeng, and usually people tell me Tianling, and I'm come from Taiwan, and I am the growth platform engineer in Merpay since 2021, and I started to write Go maybe 2017, so it's like almost 5 years for me. So today our agenda is I will going to share with you about the CTF game that's holding in GopherCon, and we also were talking about a beginner session that you can build in your own game in 45 minutes. Okay, so for the CTF game, this is the first time that GopherCon holding the CTF game. And the question quite diversity is having some web security problem, but also having some code problem. And some question even is the session repository that being shared in the previous GopherCon. So one of my impressed question is that I'm trying to solve a snake game in Golang, and it have the two label, and one label is there have a binary file that generate by the Golang code, and one flag is being hiding inside the binary file, and another one is a flag that inside the code. So you need to read the code very carefully, and it will show and understanding all the logic inside the game and trying to play the game, and you will get the flag if you finish the game successfully. So it actually take a lot of my time to read all of them, and also I found this game actually is the last year GopherCon sharing game, so it's quite funny to me. Yeah. And another impression game that I've been solve is about the web security problem. So they have one website, we also have two label. So the first label, the flag is being hiding inside the user page, but you only have one login page. So you are trying to use the path to check if you can see the secret data or not. And I found that if you like hash user and you can see the user data, so I'm trying to get all the user data and trying to get fetching the user data and found there have one flag inside, but there have the level 2 is about to log in the website. But unfortunately, I didn't have so many time to playing the CTF game, so I didn't found the way to do the password. And also, unfortunately, that the organizer is not going to share the answer, so we cannot be reduced to see the answer. How can we do that? Yeah. So for the CTF results, so I'm being answering around like 7 questions, and there have some tips you can be using your score to see, so the score become low. But I think my highest is like 1,800. And they also planning to hold on next year, and you don't need to do anything. You just need to register the website and you can join the CTF. And I remember if you win the game, they will give you the next GopherCon tickets. So if you are interested about this part, and you can try to join next year. Okay, so for another session I want to talking about is about from zero to hero to launch your own game in 45 minutes. So it actually have a GitHub repository. If you are interested, you can try to access that. So this is a game that to feed the Gopher, and when you feed the Gopher, they also will have the chat room. It's quite funny to see the game screenshot. It's like you just continue to feed the Gopher. So it's quite simple game, just like counting the score. And why it can become so fast is because they are using a Go mental framework, and it can build a website kit and also can help you to management your cache, and can also using the AI to generate your code. And I really like the idea that the presentation saying about that we are looking forward to see more people to writing the game in Golang. So people now are trying to writing the game with like Unity, like React. So it's really interesting to starting to writing the game with Golang. Yeah. So let's see a little bit about their code. So as you can see, this is the part of the code of the chat room. And it's quite simple. It's just holding a web socket, and you just subscribe the socket and to getting the data. And another one is about the feed. So feed is just kind of like the score counting, and you can getting the data by click the screen. And the code inside this repository is quite simple. So if you are a beginner of the Gopher, I'm really recommending you can try to do by yourself one by one. And it actually this session should be the workshop, but somehow it become a opening. Somehow it become a session inside the conference, but it's still a very good start up for you to start Go. Yes, that is for my presentation.
Tianlin, thank you for your presentation. Your presentation, the session you attended was also curious about it. And was this session presented to the such device like devices? No.
Device.
Yeah, device like you at the time you show off the some devices as a gift through attending the workshop. Was this session?
No,
the
it
same?
is
No.
another one. It is this
Okay, got it.
session is be holding in it's on Thursday morning.
Okay,
So
got it.
it's actually it should be a workshop, but I don't know why it become a session in the conference. And it actually is kind of like you really can build your Go game in 45 minutes. So it's really a very simple structure, and you can try in the very beginning to writing the Go game.
Okay, understood. Thank you for clarification. Okay, so it seems to me that there is no additional question from the X or YouTube. So I want to move to the next presenter. Again, thank you for your presentation this time.
Thank you.
And the next presenter will be Ma'am. She will present the navigating the series of data migration journey. Ma'am, are you ready?
Okay, hello everyone, and welcome to today's session, the recap of GopherCon 2023. And I will be sharing an intriguing journey about Bitly, that how they navigated the vast seas of data during their migration process. But before we start, a little about myself. My name is Manpreet Kaur. I'm a backend engineer in Mercari, joined in October 2021. So after joining Mercari, I've been working with KYC team as a backend engineer. Before joining to Mercari, I was working in Japan with an e-commerce company. And prior to that, I was working in India and worked for banking, telecom, and e-commerce domains. Okay, so today's focal point will be Bitly. Bitly's software engineer, Zoe McCormick, a passionate engineer experienced in distributed system, databases, and microservices, presented an interesting topic during GopherCon 2023. And this session is a sneak peek of her presentation about the data migration journey that Bitly did. And we will explore how they migrated 80 billion records from MySQL to Bigtable. All right, so the agenda for today's session would be covering these topics. First, we will understand about Bitly and its colossal data, then recognize the challenges that they have with the MySQL setup, and then we will dive into the solution that they brought up with Bigtable, and then discuss their meticulous migration strategy. And in the end, we will discuss some of the fruits that were paid off as their part of their labor. So first, about Bitly. So many of you might recognize Bitly as the URL shortening service, but it's more than that. So it's a powerhouse of link management and analytics, enabling businesses and individuals to share and track their links globally. About Bitly's data, so under the hood, the data is organized as a key value pairs, key being the shortened URL, and value will be the original URL. So on a daily basis, they process about 360 million links and QR scans, and they generate 6 to 7 million new links and QR codes. And amazingly, they have about 40 billion active links under the management. I'm discussing this data, these stats, because you can understand this much of data, will definitely have problems when, during the migration. So that's what happened. So managing this colossal data wasn't, a walk in the park. So they grappled with self-managed, manually sharded MySQL setup. All they have to not only keep 100% available to their customer, while maintaining the manual shard, it does help them having a good key distribution across their logical and physical shard, but it was pretty high maintenance and error prone when they were making any changes to sharding config. So these limitations that come with the manual sharded MySQL, along with the scalability issues, operational tasks, and their needs for software and security upgrades, that become problematic for them. And even backing up this amount of data consumed almost entire day, and restoring would take days. And according to their estimation, they said that it would have undoubtedly taken at least 2 people working for several days to restore the data. So they needed a system that is set up more towards their increasing growth and reliability, preferably one that has built-in functionality for replication and scaling. So here comes the Bigtable, a Google Cloud's NoSQL powerhouse. It boasts an impressive SLA, and it offered limitless scale with swift responses, and also come with features like multi-region replications, monitoring system, on-demand scaling capabilities, which helped adjust their user traffic and allows the system to grow and scale as needed. So since they use Google Cloud Services for many other services in their system, including the APIs that interact with the databases, this decision of choosing Bigtable, helped them achieve a seamless integration with their general existing architecture. So they saw light to address the problems and fix the issues, mainly around scalability and backup with the Bigtable. So once they decided that they are going to go with the Bigtable and their rationale behind choosing Bigtable, next was designing the migration strategy. So migration was a delicate process. They began with preparing Bigtable with the right schema that is appropriate to their needs and the schema requirements. Then they did the application code change according to the so that it can be integrated with Bigtable. After that, they first started writing dual writes to both the databases, MySQL and Bigtable, simultaneously. And then they started the data migration scripts. So these scripts were written in Go, and while execution of these scripts, they also clean and backfill older records. After that, they initiated a cutover time, which is reading from Bigtable while continuing to write to MySQL as a precaution, so that in case they have to roll back, they have all the setup in place. So after all this rigorous steps and the data validation, stability check, they ceased to write to MySQL and finally migrated to Bigtable, and they got rid of MySQL. So this was a challenging journey, and this journey also bore some fruits. Bitly now enjoys scalability like never before, and its ability to scale seamlessly over time while improving their system SLA was a major factor while choosing Bigtable. Not only did it met their technical requirements and operational needs, but it helped them set for the future growth. And also they achieve higher availability SLAs. And in terms of data security and backups, they have triple layer backup defense system now. Bitly rests on a daily Bigtable backups, and then another backups that are done in cloud storage, which is executed weekly. And they used data flow jobs to export the data from MySQL to Bigtable, into cloud storage. And then they also planned some restoration procedures in case of, they need to restore the backup into the main database. And with this, I would like to thank you all for joining this session today. The Bitly story underscores the importance of choosing the right data solutions and the benefits that follow after. With this, we have come to the end of this topic, and I appreciate for your time and attention. Thank you so much.
Man, thank you for your presentation. This presentation was really exciting challenge to migrate a bunch of records from the MySQL to Bigtable. And one quick question for your presentation. Is there any chance to try to tackle such migration from some RDB to Bigtable in your project or other your personal project?
Yeah, I'm glad you asked this. We have something similar planned in our service in KYC. So I can't reveal all the details, but we do have a similar set of challenges that we are tackling with. And I was, fortunate enough to attend and gain some insights from Bitly's journey. But it's soon there. I'll share more details once it's done.
Yeah, I'm glad to hear that. Really excited to hear that. I'm looking forward to hearing the such challenging results in the future. Again, thank you for your presentation. Okay, let's move on to the next presenter. Next presenter is Amit. He will be present the GOO piece, talking about Go and OO piece. Amit, are you ready? Okay, I'd like to pass on the mic.
Okay, nice. Hello, everyone. Good afternoon to you all. I'm going to talk about one topic, which I'm naming as scopes. I came across this topic during the GopherCon event, which I attended, and most of the concept and I'm sure that you all people should be aware of it, but it's always necessary to bring those concepts while you're writing the Go code, right? So it's majorly for the people who have previously worked in OOPS and now they have started working in Golang. So let's see what's this GOOPS talks about and how to break the muscle memory of OOPS. So let's move to the next slide, which basically talks about my introduction. So hello once again, my name is Amit Kumar. I'm originally from India. I have almost 12 plus years of industry experience in architecting, designing, and building scalable products with Mercari. I'm working with them since March 2020 as a software engineer. Moving on to the next slide, which will talk about what is Go. So it is when Go and OOPS is combined together, I'm terming it as Go. Okay. So the idea is that most of us have previously worked in other languages before starting in Go. What are those languages? Has been either C, C++, Java, something like that. One thing other to note is Go is not OOPS. That's clearly mentioned in Go documentation. And if we try to apply those OOPS way of writing a Go code, that's not right. That's not ideal. And you will face you might be able to get things executed in near time, but in future, that's going to lead to lots of problem. So let's see that what are those signs to avoid Go. Okay, so example of groups. There are various other examples. These are some of the prominent one which I have picked up. So the first one talks about creating separate shared components to resolve codependency. If you basically talk about codependency isn't that specifically tied to a language itself, right? Codependency in software development refers to a situation where two or more modules depends on each other, okay, and leading to a tightly coupled and potential maintenance issue. So codependency should be avoided. The next point is declaring interfaces as exported provider extractions. So interfaces in both OOPS and Go are tools that helps us to enable abstraction and facilitate polymorphism. Now, when designing software in either of the languages, OOPS or Go, understanding the idiomatic way of using those interfaces or their equivalent is crucial. Each language has its own strength and pattern, and that makes them unique about the implementation. So here is what I want to say is let's not mix the Go way of OOPS way of doing the things in Go. This is one of the other good, nice example of OOPS. Talking about the architectural patterns, we know there are, I'm sure all the engineers here must be aware of various architectural patterns like solid, or you talk about clean code or KISS, try, YAGNI, whatever. The point is, again, we should avoid groups while making those architectural pattern implementation. So let's see what we can do in other slides. Okay, so I'll move to other slide here. Okay, nice, thanks. Okay, so let's talk first about separate component to resolve codependency. What are the sign of groups in such kind of cases? First thing is avoid packages name which starts with like base, client, and interfaces. Okay, Go doesn't suggest those kinds of names. Okay, the next is like packages that only contains interfaces and structs with no behavior. Basically, if you talk about Go way of doing the interfaces, Go interfaces generally belongs in the package that uses values of the interface type, not the package that implement those values. Okay, I'm sure you might be aware of these concepts, but the important is that you bring it to the implementation when you're writing the Go code. Okay, let's move to the next slide. Talking about the interfaces as exported function. Of course, using the good name for the interface is important. One method interface are named by the method name, plus we add underscore, we add some suffix as er, okay, or similar, right, to construct the noun of and the name. Okay, and the important point is let's avoid the methods starting with IMPL or similar suffix. Those are the sign of groups. In OOPS, we'll be doing IMPL or something like that. Let's not do that in Go. That's important to realize. Okay. And of course, the interface redeclares every method on the interface struct. So this is also one of the important things that in Go, this might lead to redundancy, confusion, and various other potential issues and maintenance overhead. So let's avoid those things. Okay, talking about the architectural patterns, I think let's go in deep about solid and clean code, wherein we'll talk in deep like what can be done to avoid. But the overall point to here, the sign of group is that package name for kind of things that mirror the pattern layer. So it's always important to have the layered approach while implementing those architectural patterns. Okay, types are repeated in each package, so that could be one of the signs of your group. Okay, the change in one package could impact multiple packages. Okay, so that's one of the other sign of groups. Your project could be good in isolation, but when it comes to cross project integration, it becomes difficult. That is another sign of group. So let's avoid doing those things. So I'll just skip this part and I'll go to the clean architecture. So of course, we know that the idea behind the clean architecture is to separate the application into layers to achieve the separation of concerns, making the system more modular, maintainable, and scalable. Okay, and of course, how can we do? We divide the whole project into 4 code bases, 4 structures like entities, use cases, interface and adapters, framework, and drivers. Of course, there could be multiple other layers as well, depending upon your use case and need. But these are the 4 basic that has been suggested as part of the clean architecture. Okay. Talking about the solid, of course, there are 5 principles that apply to solid, starting with one important thing to remember is that OOPS solid is basically phrased in OOPS terms, but it can also be adjusted for Go in a better way. So there is no doubt that we cannot use solid for Go projects. So keep that keep that in mind while implementing the Go code. Okay, talking about the open closed principle, which is first thing. So basically, the software entity should be open for extension but closed for modification. In Go, you can achieve this by using interfaces. That's important to understand that in Go, you can achieve this open close by interfaces by defining behavior using interfaces and having your structs implement those interfaces. You can easily extend the behavior without modifying existing code. So yes, talking about the interface segregation, clients should not be forced to depend upon interfaces they do not use. That's an unnecessary overhead. Okay, Go encourages small and precise interfaces. Okay, the biggest example is your input-output reader and writer. Okay, so you can take a look at those packages, and that could give you the detail of the way to have the interface segregation. Single responsibility. Yes, in Go, you can apply this principle to packages, structs, and function. Each package or functions should handle a single responsibility and should have only one reason to change. Okay, let's go to the dependency inversion, which says that high-level modules should not depend upon the low-level modules. Okay, and both should depend on the abstraction. That's an important factor to remember. As said, like there is a great rule of thumb in Go that accept interfaces and return structs, and you might read in lots of maybe in blogs and all those things, right? So dependencies in Go can always be inverted using interfaces. Instead of having some high level of code depending upon the concrete implementation, you can have it depend on interface abstractions. That's one of the approach you can take. Okay, I think that is what these principles talks about. I'll talk about this list scope substitution principle as well, which is mostly related to inheritance in traditional OOPS language. Okay, in Go, how you can do it? This is applicable again to interfaces. If a type satisfies an interface of that type should be able to use anywhere, should be able to be used anywhere the interface is expected to be. So that's about the substitution principle. Okay. Yes, important. There are too many things. It's always important to revise the things. So remember that Go is not really an object-oriented language. Okay. Understand the idea behind those OOPS pattern and practice them in writing the actual in actual idiomatic Go way, not the OOPS way. Okay. And of course, as the Go proverb says, clear is better than clever. So the overall point is breakdown. From this slide, I wanted to break down what you have learned as part of the OOPS and have the same concept implemented in Go way, not the OOPS way. I'm sure you are aware of all these concepts, but implementing it is the biggest thing. So my point here through this event was to highlight you need to be aware while implementing what you need to be aware while implementing the Go code. I think that's it from my side. Any questions? I'm ready to answer. Thank you very much for your time today. Thanks a lot.
Thank you for your presentation. Yeah, the session you joined is one of the really I can say insightful perspective.
Yeah, this is being done by every developer, and it's important that, and we are aware of all the concepts. It's important that we bring those concepts into implementation, and that is what I have been speaking on during my whole even 10 minutes of time. That's important to bring into implementation.
I see. If you don't mind answering it, I want to ask this question. As far as you can tell, is clean architecture or solid such some principles already in use in your team?
Yes, exactly. So I could say that not all the teams. Again, we as a developer are free to do what we want to do. But if you want your project to be highly maintainable, testable, if you're thinking about the long-term aspect of your project, that once you're not there, someone else is supposed to be maintaining that. Okay, these things are important. I, as an engineer, I always encourage my team to do all these implementations, to take care of solid and not only solid and clean code. There are many other principles we should always be aware about making while implementation.
Yeah, it sounds great to me.
Yeah.
Again, thank you for your presentation. I'm really into your presentation as well.
Thanks a lot.
Yeah. Okay. So let's move on to the closing session. And as of now, all presenters finished their presentation. And I want to move on to the closing session. Please allow me to speak Japanese from now on. So, これで、メルカリ Go24 の、会を、終わりたいと思います。この会を終わる前に、皆さんにお伝えしたいこととしては、次の回も、良くしていきたいと考えていますので、今回の、回の、フィードバックをいただきたいと思います。アンケートの URL はこちらになりますので、こちらの URL もしくは QR コードから書いていただければとありがたいです。Please, we wanna hear the feedback from attendees this time to keep improving our Mercari Go event in the future. So it will be great for us to hear your feedback. If you're interested in the feedback, please give us your feedback via this Google Form link or QR code. Yeah, that's about it. それでは、今回のメルカリ Go24 回を終わりたいと思います。ご清聴ありがとうございました。So it's time to end up the Mercari Go 24. Thank you for your time and hearing this our presentation.